Hi, Algebra 2. In Chapter 11, Lesson 2 here, we're going to be working on graphs of other trig functions, mainly the graph of tangent. Here we go. Here is an example of the graph of tangent, and you notice that it looks weird. It is periodic because it's repeating over and over exactly, but it has a whole bunch of asymptotes in it. And that's because if you remember back to the unit circle, the tangent of an angle is going to be equal to the sine divided by the cosine for that angle. So for example, the tangent of pi over 2 right here is going to be equal to 1 divided by 0. And we can't divide by 0. So when you see pi over 2 on your graph of tangent right there, it's going to be an asymptote because the line will reach or will approach it but never cross pi over 2 because you can't find the tangent of pi over 2. It is undefined. That also means when we're talking about the domain, the possible x values, they're going to say that x cannot be pi over 2 plus pi n, meaning every time we go another pi over on the graph, a distance of pi, there's going to be another asymptote. We can't have that value. It is going to be undefined. The period of the tangent function is going to be pi, which is different. Sine and cosine had a period of 2 pi. Tangent is just pi. And the amplitude here is going to be undefined because you see these arrows. It's going on forever, up and down on our graph. So we don't have that maximum and minimum value that we do with sine and cosine. You can do transformations with the tangent graph. And what we're mainly going to focus on is just the amplitude and the period. We're not going to worry so much about the shifting here with tangent. To find the period, you're going to use pi divided by b when b is coming from the tangent equation right there. And then the other thing we're going to be looking at are the asymptotes, and they're going to be located at different intervals. So we're going to find those intervals. We're going to find the first asymptote, and then we're going to find how often they happen. And finding these values, the period and then the asymptotes and how often they happen, is going to allow us to graph our new tangent graph. We are not going to do much with A here. A is going to just determine like how quickly it curves near the curving part of the tangent graph, and we're not going to worry about that in our graphing. To find the period for this, we're going to do pi over b, which in this case is this 2 right here. So we can just leave it like that. The period is pi over 2. The x-intercepts, well, tangent itself has an x-intercept at 0. So there's going to be another x-intercept every period or every pi over 2. So we can say pi over 2 times n, meaning if n is an integer, every single time you plug in a number for n, there's going to be an x-intercept there. So we can just put those in here, every pi over 2. And then the asymptotes, we're going to use the equation from the previous slide, which is pi over 2b, the absolute value of b, and then plus pi n over b. And our b here again is 2. So we're going to end up with pi over 2 times 2, which is 4, plus pi n over 2. Now again, this means that our first asymptote is happening at pi over 4. If you notice, it's going to be halfway between those x-intercepts. And then this part of the asymptotes is telling us how often it's going to happen. And that means every pi over 2. So if I have pi over 4 and I add pi over 2 to that, that's going to be at 3 pi over 4. Now just notice it's going to be halfway between those x-intercepts. Now again, we're using tangent x as a guide, and that started at the origin and started with our first curve going upward. So I'm going to draw that one in, and then that kind of gives me a guide for the rest of my graph. And we'll just put these in there. In this graph, the period is going to be pi over 1/2, or pi divided by b, coming from right there. And that's going to be the same as 2 pi. The x-intercepts are going to happen at every 2 pi, or 2 pi n. And that's because tangent has a y, or excuse me, an x-intercept at the origin. And this means that then the next one would happen at 2 pi if the period is 2 pi. So I can already see that this is going to make my graph really spread out. So I'm going to extend it out here, and I'm going to put in a mark for 4 pi and 3 pi so that I can put one more x-intercept out here at 4 pi. For the asymptotes, I'm going to use my equation pi over 2 times b. In this case, our b is 1/2, plus pi n over b, which in this case is 1/2. That's going to simplify to just pi plus 2 pi n. And as a reminder again, this means that our first asymptote is at pi, and then it's going to happen every 2 pi. So I can put in an asymptote here at pi, and then at another 2 pi, that's going to be at 3 pi. And again, notice those are halfway between our x-intercepts. And to finish out our graph, we know that tangent starts at the origin and goes up, and so I can draw that in right here. And then I can do that with every piece of my graph. Notice that this one is really stretched out, so it's nice to extend that axis so you can see the graph a little bit better.